say we want to graph the region for which x plus y is less or equal to 1. What points would satisfy this equation? Well, we can reorganize that a little bit by saying y is less than minus x plus 1. And so now we can graph the line y equal minus x plus 1. Okay, so it's a line of gradient minus 1 and go for plus 1. So that goes like this. Oopsie. Yes. So y equal minus x plus 1. So when does y is less than minus x plus 1? Well, that means that we are below here, below this line. So that's the region x plus y is less than 1. Well, we can check. Let's pick a point at random, for example, the origin here. For the origin, we have x and y which are equal to 0, so 0, 0. And indeed, x plus y is equal to 0 plus 0, which is 0, which indeed is less than 1. Now, slight variation, if I had x plus y strictly less than 1 and not less than equal, well, that would be exactly the same thing, except that the line would not be included into it. So to show that, we just do the line, but then we just do the line, oopsie. We just do the line as broken line. And that shows that the line is not included. Okay, let's do another one. Or actually, let's do a very easy one first. Okay, so y less or equal to 2, well, easy. That's basically the area of the plane such as y is less than 2. What about this one? X greater or equal to 1? Well, again, easy. That's the area of the plane such that basically to the right of the line x equal 1. Now, if we have the two together, x greater or equal to 1 and y less or equal to 2, well, so that's the intersection of both. So in that case, that would be this area here. Okay. What about this one? Find the intersection of y greater than x squared minus 1 and y less or equal to 3x plus 3. Okay, so first we are going to graph y equal x squared minus 1, which is a parabola, concave up, because the coefficient of the x squared is positive. And compared to y equal x squared, it's just moved 1 unit down. So that would be like this. And here it's 1. And just not to be confused, I'm just going to do this one in blue. 3x plus 3. So what we do is we graph y equal 3x plus 3. So actually, coming back to the first part, one black, when is y greater than x squared minus 1? Well, that's when we are above the parabola, so all of this part. Now for the blue part, we just graph y equal 3x plus 3, so 3x plus 3, that 3 cuts here, and then the gradient is 3, so it would look like something like this, basically. Yes. Because that x equal -1 here, y is equal to 0. When is y less than 3x plus 3? Well, that would be below the line. So here. And when are the two conditions satisfied at the same time? Well, that would be here. I think they intersect probably somewhere up there. So it's a closed area.